Welcome back, everyone. We have a new talk. So November 2022 marked the release of .NET 7 and C# 11 releases. And in this session, Johnny will talk about the latest and the greatest, and also what the future will bring for the .NET platform in general. So Johnny Hooyberghs is a consultant for Involved since 2014, who's focused on .NET architecture and backend development, and a Microsoft MVP since 2020. Since 2010, Johnny spends some of his free time teaching .NET and C# for the Adult Education Institute, CVO in Antwerp. And when he's not working or teaching, he likes some casual gaming, scuba diving, learning to play the piano. I would love if we get a little demo of that later. Also traveling the world and I love this, visiting as many theme parks as possible. So I expect a lot of questions from our audience about which theme parks were your favorite. And otherwise, please take the stage whenever you're ready.
All right, thank you for that awesome introduction. Hello, everyone. And yeah, I'm here to talk about what is new in .NET and C#. And exactly right, last year in November, we had the new release of .NET 7 and C# 11, but also this year in November, we will already have .NET 8 and C# 12. Because Microsoft is already working on those new versions of both .NET and C#. I can also already give you a little sneak preview into some of those new features that we can expect this year in November. So let's go very quickly over this slide. You already had the introduction about me. I'm from Belgium. I'm very happy to be here talking to you on .NET. The only thing you need to remember from this slide is that I have a GitHub that contains all of the examples that I will talk about today. So you can find a very specific repository on .NET 7 for Dev Days Europe 2023. And if you scan this QR code, it will guide you directly to that repository. Today will just be a long list of new features that I like, and I will just show them to you from Visual Studio, from code. So there's not a lot of slides actually. Well, there is some slides if you like them, but they just have a large list of all of these features. For example, this is a list of the features that I can talk about for .NET 7 specifically. This is a list for features of C# 11 specifically. And then I can also talk about new upcoming features for .NET 8 and C# 12. But instead of just reading these slides, let's go right into some code, if I can find my Visual Studio, and just show you from there. So I don't have a lot of time. If I really want to dig deep into all of these features, I need a couple of hours of time to present them to you, which will probably be a little bit boring. So I will just pick the ones that I find the most interesting. So I will go back and forth between .NET and C# so that there's something for everyone. So yeah. In this solution, which again is on my GitHub, available for you to download or to watch or to fiddle around with, there is a list of folders, and within these folders are these new features. So let's start with some very easy features, some very simple features. So there are a lot of additions to the base class library in .NET 7. So the base class library is the base class library you can use as a developer with methods and with classes and methods already inside of them that we can use to leverage them in our applications. So a very, very small one, for example, is the support for microseconds and nanoseconds. So all the types that we have available in .NET that support some kind of time, like daytimes or time spans, they now have additional properties that will also tell you the amount of milliseconds, microseconds, and nanoseconds. So milliseconds was already there, but now we have, in addition to that, microseconds and nanoseconds. That does not mean that if we use timers, for example, or stopwatches, that they will be precise up until that one single nanosecond or microseconds. No, that's not true. The reason that those properties are there is because we can now use them to do calculations. So we can create a time span, or we can create a daytime. We can specify a very specific number of nano or microseconds, and then we can do calculations based on that, which can be very nice if we are writing scientific software. for example. Now, things like constructors also support these new features. For example, the constructor for a time span now has as a final argument the amount of microseconds that we can add. So this is a very, very short time span that only lasts 1 microsecond, for example. And then, of course, you have the properties total microseconds and number of microseconds within milliseconds. Cool. Very easy feature, very easy to talk about. Another one that's quite small, for example, is, let's see, generic math. So generic math is a new feature where there's a new interface called iNumber. So we all know that C# and .NET, C# is a type-safe language, and .NET, of course, supports this. Type-safe language means that it's not that easy, or not, it doesn't happen automatically that one type is converted or mapped into another type. So there's a lot of number types in .NET available. We have integers, we have floats, we have doubles, we have decimals, we have bytes, we have booleans. All of these different types represent different kinds of numbers. But in math, all of these numbers can act in a very specific way. We can add two numbers together, we can subtract numbers, but they are numbers. And in C#, there's multiple of these types. And that's the reason why we have so many overloads for many of these methods available in the base class library. If you want to do calculations, you will see that there's like 16 or 18 overloads that support all of these different types. Well, now with .NET 7, finally, we have an interface that lives on top of all of these numbers, which is the type iNumber. And a lot of these operators and methods and things we can do to change or to work with numbers are now written on top of iNumber instead of the specific types in .NET and C#, which means that we can leverage this iNumber and we can write math functions that work on top of a number instead of a very specific Boolean or integer or decimal. In this very easy example, I wrote the calculate factorial method to calculate a factorial. For example, 5 factorial equals 5 times 4 times 3 times 2 times 1. So I can call this method using a byte or an integer or an unsigned integer or a long or a float or a decimal, and so, or a double or a decimal. And I only have to write this method once. I write it once with the generic T number, which is of type iNumber. So the iNumber is the contract that says it's some kind of number. And because I now work with all kinds of numbers, I can reuse this method for all of these different types that are existing in the .NET framework. So, of course, because constant values for different types are different, the iNumber interface actually allows you to use a couple of constants for 0 and 1, for example, because every type of number, from Boolean to decimal to whatever, they all support zeros and ones. Now, for the specific use case for calculate factorial, we can check if the input number equals 0 or 1. If that is the case, we can just return 1, because the factorial of 0 or 1 is always 1. Now, there's also a very specific case where when the input is 2, I don't need to do 2 times 1, because that's just 2. So I'm going to return 2 if the value equals 2. But 2 is not a constant number for iNumber. So what you do is just add 1 and 1 together to get 2. So if you add 1 constant plus 1 constant, you have 2, and now you can equal 2. And then, of course, in all other cases, I'm going to use recursion to call the same method once more with the value -1, again, using 1 as the constant number. So that's it. With iNumber, you can now write generic mathematical functions that work for all types that implement this iNumber. If you, by the way, dig a little bit deeper inside of the iNumber interface, you will see that it actually has a couple of other interfaces that make all of these operations possible. For example, you have iComparable, because numbers can be compared. You have a comparison operator, which is the equals sign. So now this iNumber supports the equals sign. You have the modulus operator, which is the percentage sign for the remainder after division. And then there's a number-based clause that even has addition, decrement, division, equality, increment, and so on. So all of these things are now inside of these contracts, interfaces, specifying that these operators are available for all of your numbers. All right, let's go to the next one. A thing that I really like and that I will probably use is another addition to a base class library feature, which is the memory cache. So inside of your .NET applications, you can use the iMemory cache, which will give you a memory cache that you can use to add values to and then use those values later from a memory cache. So it's not a distributed cache like Redis. This is just a purely in-memory cache. And this in-memory cache has an additional feature now that you can enable by allowing it to track statistics based on the size of elements that you put inside of your cache. You can optionally track those statistics. By default, we are not going to track them, but you can enable them. And you can enable the limiting of the size. So you can, for example, pick an arbitrary number like 100 and say that that's the limit, the size limit of your memory cache. Now, when you set or add items to your cache, you will need to specify the memory cache entry options with the size property to also specify what the size of the item is that you're adding to the cache. So size is more like a value that you will use for whatever purpose you need it. It is not something that will be calculated automatically by the memory cache. So it's not the size in bytes per se, it's the size as you specified what the size is. For example, if I put a string inside of my cache, I, as a developer, could say, okay, let's say that the length of the string will be the size of the element, which means that if I have a total size limit of 100, I can only put strings inside of my cache that will amount up to a total of 100 characters in total. Of course, you can still put other things in the cache, but you always have to specify the size. And if you don't specify the size will be 0 by default. So it will not take any room. So again, that's an arbitrary value that you specify as a developer beforehand. If you just want to increase the size by 1 with each item you add, you just put the size to the number 1 each time you add something. Now, when you ask the cache for get current statistics, you have the availability of a couple of properties that will tell you what is the current entry count. So how many items are within your memory cache right now. There's the current estimated size, which is what is the size added together for all of the elements within your cache. And then you have the total hits and the total misses, where hits means how many times have I asked for something that should be in the cache and I actually got it because it was available in the cache. And misses will be how many times have I asked something from the cache while it was not yet in the cache, which means that I missed the item because it was not there. So these statistics can maybe help you with your debugging or getting some statistics within your applications. All right, let's move to C# for now, and then go back to .NET 7, so that again everyone has something fun. If somebody is a fan of C#, let's take a look. We can also start very simple here. One thing that finally works now that I actually needed in the past, which is very easy now, is in C# a couple of versions ago, they introduced the name of keyword. And the name of keyword would, at compile time, take the name of a variable or a type or a property or whatever, and it would make that into a string so that we don't have magic strings when we are coding our applications. Because magic strings, they're always dangerous, because when we change a variable name, the magic string will not be changed automatically. So when using name of, we can use refactoring to change variable names, and then of course this name of will automatically change also, which is a very powerful feature. But up until now, we were not able to use name of for a parameter or an argument for a method, because in theory, if you look at this, the message in the attribute on top of this method is actually out of scope. It's only declared as an argument within the signature of this method, which sits below the actual argument. In theory, we all know as developers that an argument on top of a method is actually is actually living for that method. So it's used on that method. So it should really be in the scope of that method. And that is something that the C# team has now changed. So the message will now be a valid variable even outside of this method, because within the argument that lives on top of the method, it's actually part of that method. So that will actually be recognized. If you change the version of C#, you will get the red squiggly line that says the message is not a known variable within this context. Again, this is a new feature for C# 11. All right, another feature, very weird but maybe cool feature, is file local types. So I can create a class like I could do before, and I can have an access modifier. Access modifier can, for example, be public, which means that the class will be available everywhere, even from separate assemblies that call into my disassembly. There is private, which means it's private only for this specific parent class. There's internal, for example, which means it's public, but it's only public within this assembly. So I can't get it from outside of this assembly. But now in C# 11, there's an additional access modifier called file, which means that this class is only valid within this physical C# file. So if I have this class helper, I can create a new instance of the class whatever, because the class whatever is specified within the same file. But if I go to my program.cs and I do console write line new whatever, the whatever class cannot be found because it is specified within a separate file, not this C# file, but another C# file, and it is file scope. So it's only available within that file. So if you are, for example, writing a lot of helper classes that you only need from another class, for example, that lives in the same file, and you don't really want anyone to use that helper class except for you yourself within that other class, you can make that file scoped. And the cool thing about file scoped classes is that they can have the same name when they live in different files. So you don't have any name problems there. So name collisions are not your issue because the file only is valid within that file, and the class is only valid within that file, and it will not collide with a class in another file, which is cool if you do a lot of helper classes, for example. All right. What do we have still? We have, oh, this is a cool one, list patterns. So C# is investing heavily in what they call pattern matching, where they are adding patterns to the language that will actually be lowered to a whole lot of code that will be compiled for you instead of you having to write all that code yourself. One of the example is list patterns. So you can actually use within a switch statement, which is already a new pattern in a couple of versions of C# ago. You can do stuff like this. You can, for example, switch on an array of integer values, and you can specify that you want to do something or you want to return something only if the array starts with the values 1 and 2, then has a number of values in between, can be 0, can be as many as you want, and then needs to end with the value 10. So this is a pattern matching where you basically tell the switch statement, well, this array needs to start with 1, then it needs to have a value 2, then it needs some arbitrary number of values in between, and then it needs to end with 10. Again, where the double dot specifies an arbitrary number of items in between, can also be 0 items. So it can be an array of 3 items, 1, 2, and 10. And then it will succeed and it will return 1. Then this is the literal array of containing 2 values, 1 and 2. So when the array contains 1 and 2, it will return 2. And then this one uses the discard operator. So in the C#, the discard operator can discard something. So in this case, we're using it to tell the switch pattern matching statement that the array needs to have exactly 2 values, and the first value needs to be 1. The second value we don't really care about. And in that specific case, we will return 3. And then in the fourth case, the array just needs to start with 1. It can be the only element, or it can have multiple elements behind it. But then in all of those cases, it will return 4. And then finally, this one is a really stupid one because it just says the array can be whatever. It can be an empty array, it can be an array with 1,000,000 items. I don't really care about the items, but in that case, return 50. And it becomes even more crazy when we look at capturing slices. You can do the same pattern matching scheme, but you can use a variable to capture the thing you're really wanting to do here. So for example, an array that needs to start with 1, then has an arbitrary number of items in the middle, and then it needs to end with whatever value. So basically we're skipping the first item, we're skipping the last item. The first item needs to be 1, and then all the items in between we are going to capture in a new array called middle. And then we can reuse that new array middle that contains all of these middle items. Again, just put the double dot for any arbitrary number of items, and then add a variable just after that to capture those values and put them in a new array called middle. And the same here for the whole array. I'm just capturing the whole array again, which is a stupid thing, but you can see how that should work. Cool. Let's go back to .NET. What else do we have? Maybe a little bit more complicated feature now. We have something called gRPC for .NET Core. gRPC is kind of a web service technology that does remote procedure calls between web services. So maybe you have two microservices, and those microservices are now talking to each other using the new gRPC, which is available a while now in .NET Core. It was introduced some versions back. I can't remember exactly which version, but we can use that to create remote procedure calls within .NET. It's very easy to do that. It looks a little bit like WCF, if you know WCF from back in those days, but it's a lot better than WCF, or a lot more performant at least. You basically specify a contract, and that contract uses the protobuf format. And that contract specifies that you have a service, and that service has an RPC method, say hello, for example. That RPC method has a request object that takes that request object in as a parameter, and it returns a reply object. That request and reply object can have a number of properties. In this case, it's very easy. Both have one property. So I'm going to request a name, and I'm going to reply with a message. The reason there's a number behind is because we need to specify the order. So one is not the value for name, one is the order for the property name. Because gRPC uses a binary protocol, it's not using XML or JSON, it's using a binary protocol, we need to specify the order in which we are sending the properties of our requests and response objects. Why? Because they will be encoded in a binary stream of data, and because of that, we need the order basically. The reason it's more performant, because when it's binary, we also are not going to use the names of the properties. And like XML and JSON, they will specify the name of the property and then the value of the property. But in a purely binary protocol where client and server both know what they should expect based on this contract, they really don't care about the names, and that will make the total size of the data that goes over the wire smaller, which is a cool thing. Now, let's get to the new feature. The problem or downside with gRPC in .NET is that it's not easy to test with your browser. As developers, these past years, we find it very easy when we write a web API, for example, to just open the browser and check our endpoints by just calling the API, if it's a GET API, and we can see the results JSON object just immediately in our browser. Now with gRPC, that doesn't work because gRPC is using a binary protocol, it's using HTTP2, and the browsers are not supporting this out of the box because a browser is created just for viewing web pages and not for doing gRPC. Now, also, when you write an application that's using gRPC and you have an external client that wants to interact with your application through your web service, and you're using gRPC and your client does not support gRPC, you also have an issue there, because HTTP is widely supported and web APIs are widely supported, we now have an additional option, which is just this little thing, that for your gRPC method will actually add the HTTP endpoint for you automatically. So you don't have to create the endpoint manually. You can just add this option, Google API HTTP, provide the endpoint for that specific HTTP endpoint, or at least the endpoint route for that HTTP endpoint, and it will be generated automatically for you. So if I put this as my startup project and I start debugging, I can now just visit that specific endpoint to call my gRPC method, and I don't need to add anything in my code. So if I browse to this small server, so it also says by default, communication with gRPC endpoints must be made through a gRPC client, blah, 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 blah. So if I instead do the v1 greeter dev days, it will now return to me message hello dev days, which is the implementation that I did in gRPC, but now also using HTTP endpoints. So I got that for free without the need to write that code myself, which is pretty cool. All right, let's shut it down again and let's look at something else. I'm going to do one more .NET 7 feature. Let's see, what is a very cool one? Well, this is a big one actually, rate limiting. Rate limiting is a whole bunch of new classes we have available within the base class library that we can also use in ASP.NET, for example. Rate limiting basically means that if we have a piece of code that needs to run multiple times, or can run multiple times, maybe multiple times at the same time for multi-threading purposes, but maybe multiple times because you have multiple users calling into your application at the same time. Now we can add rate limiting without the need for external libraries or without the need for writing that ourselves. And there's different kinds of rate limiters that out of the box are available from .NET 7. The simple one, for example, is the token bucket rate limiter. So I have written a parallel for each loop that will run 10 items in parallel, and they will use a rate limiter. So it's not going to do the 10 items in parallel, it's going to do the 10 items in parallel based on the rate limiter. Now, what does this rate limiter do? This is a very specific rate limiter called the token bucket rate limiter. And this one has some options. The options are, for example, what is the amount of tokens that you're limited to? And this can, for example, be 5, which means that only 5 tokens can be used. And when you run out of tokens, what happens is that the rest of the items that needs to happen, they basically need to wait. You can specify these options for waiting and so on within this token bucket rate limiting options. The queue processing order, which means if there are items in the queue, you can specify if it's FIFO or LIFO. The queue limit, for example, when you put the queue limit to 0, it means nobody can queue. There is no queue. So all items that are more than the limit of 5, they will actually fail. They will not get a lease and they will fail. But if you add a queue limit, you can actually have items that are waiting in an asynchronous queue until there are new tokens available. Then you have a replenishment period. So you can use like an internally built timer that will replenish tokens based on this time span. So for example, in this case, I'm going to replenish 1 token, tokens per period, each second. So each second, 1 token will be available, and if there are items in the queue, they can be worked on. If there is no queue, of course, they will fail. And auto replenishment equals true means that there is an internal timer that will do that work for you. You can put the auto replenishment to false, and you can create your own infrastructure that does that for you if you want to synchronize multiple of these rate limiters at the same time, for example. Now, this is how you configure the rate limiter. How do you use the rate limiter? Now, it's asynchronous, so you can, inside of a parallel for each, you can ask a lease to your rate limiter. So you acquire a lease asynchronously, and you will get a lease even if it succeeds or it doesn't succeed. Now, when it succeeds, you will get the is acquired property equals true. When it doesn't succeed doesn't succeed and it doesn't give you a lease, the is acquired property will be false. And then you can tell the user, there's too many people working on the application right now. Please do something different and come come back later when it's less busy, basically. But when you have a queue, the await keyword will actually wait for a new token to be replenished, and then your lease will actually be acquired, and then you can continue your work. So there's actually three things that can happen here: or you acquire the lease, or you're not acquiring the lease and it just failed, and then the is acquired is false, or you are inside of a queue waiting until you can acquire a token. And now there's different kinds of these rate limiters, and they all work in the same way by acquiring the lease, which is asynchronous, but how they are configured is a little bit different. So you have, this was a token bucket, but you also have the fixed window, for example, where you have a fixed window in time that has an X amount of tokens available, and that window, when it's empty, can be completely renewed. Then you also have a sliding window rate limiter, where you can have multiple segments per window. So your window can, for example, have 10 tokens, and then it can slide 2 tokens over every second. And now you have a sliding window rate limiter, for example. There's also a concurrency rate limiter, which just says this many items concurrently. And then you have a partitioned rate limiter, which is basically kind of a parent rate limiter that exists out of these other rate limiters underneath. So you can combine multiple rate limiters and put them inside of a partitioned rate limiter to do all kinds of freaky, crazy stuff. And why would you use this? Well, multiple things you can use it for, but of course the probably most used one will be ASP.NET. So if you created an ASP.NET Web API application, for example, you can actually use rate limiters. You can specify multiple rate limiters. You can give them policy names. So in this case, I'm providing a token bucket limiter. I'm giving it the policy name limited. And then I'm on my endpoints, I can do require rate limiting with the rate limiting policy, which means I can configure multiple kinds of rate limiters, and I can use these rate limiters on my endpoints. So if I have an endpoint that can only do a task like 5 at the same time, I can put a rate limiter on that, and I can return the HTTP status code for too busy, so that my users that are using my endpoints know that they need to back off and they need to come again later when my endpoint is not so busy anymore. Again, this comes out of the box. You don't really need any additional packages for this. You can just use this as part of .NET. So that was a little bit more intense. Now let's go to one more C# 11 feature, which is a crazy one, which is raw string literals. So in C# 11, you can now do something like this. You can actually specify a string, interpolated string on multiple lines, and you can also use the quotes, but also the curly braces literally in your string, which is very easy to represent JSON, for example, or to put JSON inside of your C# code. And of course, it also has some other use cases. Now, the way you do this is if you need a curly brace in your code and you don't want to escape it, you need to add double the $sign. Single $sign means I'm going to use string interpolation. Double $sign means I'm going to use string interpolation, but I'm also going to use the curly braces literally within my string. And in order to interpolate a variable, you're needing double curly braces. And then C# knows, okay, this is an interpolated variable because you're using double curly braces. And then to make things crazier, if you really need double curly braces within your C# code, the only thing you need to do is add one additional $sign in the beginning. And now double curly braces are literal. Do you want to do string interpolation? You need to use triple curly braces. And I probably don't have to tell you, if you want 4 literal curly braces, you can increase this way and way beyond this. So basically just add one more $sign than the amount of curly braces you literally need. And it's actually the same for the quotes. So now I'm using quotes literally without escaping them within my string. But when you use double quotes, it still works because my string starts with triple quotes. But if I want to use triple quotes, that will fail because this is now the end of my string. But if you want that, you can just add 4 quotes in the beginning, 4 quotes at the end, and now you can use 3 quotes as literal within your string, which is crazy. Gives you a lot of flexibility to do basically whatever you want. All right, let's go to some new things. So as I said this year, November, we will have .NET 8 and C# 12. Again, new versions. So what do we have in .NET 8? Very small new features in the base class library, for example, random utilities. Here, the random class where we can generate pseudo-random numbers has a couple of additional methods we can use. This method, getItems, will actually give us an array of items. How many items? 64 items that will be randomly selected out of a list of possible values. So in this case, I'm generating an array of possible values that only contains the values 0 and 1. So this is an enumerable range from 0 to 2. 2 is exclusive, so it will only contain 0 and 1. And then the getItems method will get 64 values out of these possible values 0 and 1. So we just get a binary stream of 64 zeros and ones. That's the idea. So that is one new method in .NET 8. Another one is shuffling arrays. When I generate an array of random items, which in this case is not yet random, it's just items from 0 to 31. If I then shuffle this array, those items will be randomly shuffled within that array. And then when I print them to the console, you will see that they are indeed random. Again, very small new feature, but maybe handy when you're working with random arrays. Another one, there's some JSON additions. By the way, also in .NET 7. So I will take them together maybe. So in .NET 7, we have some very small additions to JSON where we can specify a maximum depth. So today in .NET 6 or earlier, when we are doing JSON serialization and deserialization, you may have spotted an exception when your serialization goes too deep. For example, when you have recursion in your objects and you use that in a web API, the web API will throw the exception when it reaches a certain amount of depth. Because of course, when you have a recursion in your objects, the depth is infinite, and you don't want to infinitely serialize all of this. And by default, I think the depth was 64 or something. 64 was hard-coded within the framework, within the base class library, and there was no way of changing that value. Now, from .NET 7, you can actually change that value. You can increase that value more than 64, or you can decrease that value if you, for example, want to have the exception earlier, because you know that you're not going any deeper than 4, for example, you can put that max depth to 4. Another very small new feature is the patch as JSON async extension method. So we had extension methods on the HTTP client that would do JSON serialization and deserialization when doing gets and posts. But for patch, we did not yet have an extension method. And for .NET 7, we now have. Now for .NET 8, there is some additional features here where we can have JSON serialization options that disallow unmapped members, which means that if I have a piece of JSON that I want to deserialize into an object, but that object does not have one of the properties inside of the JSON, so the person has a name and a first name, but the JSON also talks about an age, by default, the deserialization will just work. It will just ignore the age property because it cannot be deserialized into a property. But when you add this disallow option, it will actually throw an exception if you want that. So if you really need your JSON to be strict, you can add this option and you will get the exception because the age property is not available on that object. And then when doing serialization, you have some additional property naming policies. You now also have snake case and kebab case next to the already existing Pascal case and the other case I can't think about. So snake case uses small letters and underscores to separate words, and the kebab case uses capital letters and little dashes to separate words. So now you have those options as well. And then to finalize, because I don't have not much time remaining, a couple of C# 12 upcoming features. This one is a cool one. We can do some crazy stuff with usings. You can, for example, create your own, let's say, custom types or aliases based on existing types. So you can do, for example, using nullable GUID equals system.GUID question mark, which means that this is now just an alias for a GUID with a question mark. If you don't like the question mark for some reason, you can just create an alias for that. But you can also use it for arrays, for example. I want an int array to just be called ints. And then I can use ints as an argument or as an argument type within my parameters. And then to make things more cool, we can actually use tuples by using complex numbers equals the tuple of a decimal real and a decimal imaginary. And now complex number is a tuple type that really has two properties, real and imaginary. So you can make a new instance, you can set the real and imaginary properties in the object initializer, and you can use those properties when you need those values back again. You don't need to create a custom type. You don't need to use the tuple of decimal and decimal. You can just use the using alias, just like you see it right here. And then maybe one final thing is the primary constructors in C# 12. The team at Microsoft that's doing C# has been talking about this for so long now, and it looks like it's going to be part of C# 12, where not only for records, but now also for classes, you can define a primary constructor, which means that you don't need to specify these values private members. They are now a constructor and private members automatically. You can add some properties that reference these private members that are automatically created for you. And you can even do a constructor overload that calls into your primary constructor, just like that. So this will give you the opportunity to use constructors, but don't write a lot of code for it. Because if you would do that before, you would need to add the constructor, you would need to add the separate private members, and you need to set the private members from your constructor, which is a whole lot of boilerplate code that you now don't need anymore. Finally. So I wasn't able to cover all of the new features. There's so many, but again, everything is on my GitHub available to you. You can browse, you can change, you can fiddle around, you can play with all of these new features if you want. And of course, you can find all of the information by following this QR code or using the URL in the bottom. I only have a couple of minutes remaining, so I don't know if there are any questions.
I'm gonna check real quick, but usually there's a little bit of a delay, so maybe they'll still come in and we have a little bit of time as the break is right after this. So thank you for this talk. I don't think I've ever seen so many demos in so little time. And I was curious if you contribute to the .NET or like projects in its larger ecosystem yourself too.
Can you repeat that question?
If you contribute, as in like open source contributions to the
very good question. Actually, not yet. I was planning to do that, but I've not yet had the opportunity to actually contribute some new features to .NET and C#. But there's many people already doing that, and the team is very open to listen to everyone's suggestions there. So if you have a cool new feature in mind, don't hesitate to do a pull request to the C# or .NET team, and maybe they will merge your feature request into their actual release.
Which is like the coolest thing ever when that happens. Yeah, I was curious about the contributor experience, but if you so openly invite people to contribute, I'm guessing that's a good one. So let's see if there's any questions.
The team is indeed open to that.
Yeah, that's perfect. And so thank you we don't have any questions. So thank you for your elaborate demos and like giving us a peek into what's to come this autumn. And for everyone watching, have a wonderful lunch if that's your time of day. And otherwise, see you back in a little bit in this track, hopefully. Thank you so much.
All right, have fun.
This is all we got. Remember the revolution in our minds. This is all we got.
Lock me out of this life institution. I am angry and high on illusions. Yes, I hate, but it's not a solution. Try my best, but I'm just a human. Oh, we don't need to say we're sorry. We don't need to worship heaven's heart. We don't need to say we're sorry.